Welcome back, reinforcement learning. This session I explained setting up the Q network and policy function. This topic, setting up the Q network and policy function for the Super Mario games for the curiosity um, uh, exploration point of view, we discuss about the setting up the Q network and policy function. The Q network we are implemented by using deep neural network. So that's called the deep. The Q function is implemented. The neural network is called the deep deep Q network. For an agent, we are represent the Q network Q function with DQN deep Q deep neural network. This is designed to predict the action values. We are using the Q function to predict the action values, which represent the expected rewards for each possible action in a state. So this section covers the architecture of the DQN and policy function for action selection and exploration strategies of the game. So in deep Q network architecture point of view, what are the, in this example we are set the deep Q network is a neural network that takes an input state and output is predicted Q values for all possible actions. So here input is a tensor of the shape, the batch into 3 into in this game we are using 42 into 42. So here batch is the number of samples, batch indicates the number of samples and 3 indicates number of channels, the corresponding to the most recent frames of the game. So the 3 indicates the number of channels of the game frames and 42 by 42. Okay, in this game we are using 42 by 42 for spatial dimension of the frame. So the batch is the number of samples, 3 is the number of channels, 42 by 42. Last two dimensions are represent the spatial representation or spatial representation dimensions. So this is the input of the state. State is the input to the neural network. So output is the output predict the Q values. Q values is the output. So output is a vector size equal to the number of discrete actions in that state. So in this we are in Super Mario games we have the 12 actions. So the output is 12 actions. So each element in the vector represents the predicted Q values for specific action. So this is the input output of the DQN. Now in DQN we implement the deep neural network is the layered architecture. So we are using convolutional layers. So the four convolutional layers with the following settings we are using to implement the DQN. The input channel is 3 to 32, 3 input channels and kernel size is 3 by 3, stride is 2 and padding is 1. These are the settings for the 4 convolutional layers. We are using the activation function is ELU, exponential linear unit activation function we are using for the convolutional layer operations. In linear layers, we are using 2 fully connected layers, 4 convolutional layers, 2 fully connected layers. The first layer is 2 into 288 times 200 neurons. 288 are input neurons, output is 100. The second layer is 112 neuron structure. So here the activation function in the linear layers, the first layer is we apply the ELU in first layer. The second layer we did not apply the activation. So no activation for the final layer, allowing unbounded Q values. So this is the architecture of the neural network. So here input is input and output. The input is batch into 3 by 3 into 42 into 42. Output is 12 actions. We have the number of discrete actions in Super Mario game is 12. So this is the input and the output. The Q values for the actions are the output. And convolutional, we are using the 4 convolutional layers. with the channels is 3, canal size is 3 by 3, stride is 2, padding 1, activation functions in convolutional layers is exponential linear unit ELU, and linear layers are 2 linear layers. First one is 288 into 100, second layer is 100 into 12. So 12 is the output actions. So in first layer we apply the ELU, second layer we did not apply the any activation. This is the architecture of the DQN. So the architecture can optionally include the current layers like a LSTM or GRU to capture the temporal patterns in data. We can apply any LSTM or GRU. In this exam we apply the convolutional layers. So the policy function. So this is the up to here we apply we discuss the DQN setup. So now the policy function, setting up the Q network and the policy function. The policy function is the mapping between the states and action rewards. The policy function determines the action selection strategy based on the predicted Q values. The policy function determines which action gives the best one. So the action selection strategy we are get from mapping. That is, mapping is policy. So we based on the predicted Q values we find the best actions. The strategies are anyone. We apply the softmax policy, or we apply the softmax policy. In softmax policy or epsilon method, epsilon grid also we applied. In softmax cells, convert the Q values into probability distributions using the softmax function. Each action is assigned a probability proportional to the Q values. So we apply the softmax policy or epsilon grid approach to explore the best actions for the in the state based on the Q values. So this is the implementation code for the policy function with softmax, and we are using the experience replay for stabilize the learning. For stabilize the learning, we apply the experience replay. To answer the training stability, the DQN uses the experience replay mechanism. So the functionality store the tuples of experiences. What the tuples of experiences means? The state, action. What the after applying the action? We got the rewards and state of the environment also changed. So it maintains the state, action, next state and rewards in a tuple, and sample random mini batches for the training. Okay, we are using to store the in buffers. So that is the experience replay to stabilize the training process. This is the code for experience replay, memory buffer and batch sampling. In batch sampling, we have stored the current state, action, reward and next states. This is the experience replay code and experience replay implementation continuation process. So this setup provides a foundational component to train the DQN effectively. The next step is we are apply the curiosity models on game environments. So we first, before going to the curiosity apply on the environment, we first set up the Q function, Q network and DQN and policy functions. Thank you.